Okay, it's been some time. It's been some time that I haven't seen you. I missed you, but it seems that you missed your friends more than you missed me. You're gonna see your friends all the time. I will be gone after next week. I mean, from this course. I will be here, of course. Okay, so give your attention to me. Now, today we're gonna talk about linear programming. And I am distributing the lecture notes, but I will be writing on the lecture, I will be writing on the board and make you some explanations with my beautiful gadget, okay, that I'm going to show you now. Okay, anybody's birthday today? Anybody who has a birthday today or this week? Okay, good. So just for them, we're gonna have, no? Okay, can you see that? Happy birthday, okay. So, I have other things that I am keeping until your 4th year, okay? I'm not allowed to do all the tricks, but I will just use an arrow, okay? It doesn't mean anything else. Okay, now, so this is very standard arrow. Okay, now about the exams. Exams hopefully will be ready on Monday. Okay, it takes some time. You have a homework which is due Tuesday. We're gonna hopefully grade that homework before we submit the initial grades, FZ grades. Okay, and your exam will be on the 26th, no, 26th of May, which is a Sunday. So we're gonna be here on a Sunday. I was thinking of bringing you some simit and chai, but unfortunately for 200 people, I need to hire a carrier to do that. So you can bring your own food. Food will be allowed and drinks will be allowed during the exam, but not other things. Okay, any questions that you want to ask before we start with today's lecture? Okay, now today we're gonna see one of the, okay, I need your attention now, please. Okay, today we're gonna see one of the most famous method of industrial engineering. This is called linear programming. It's actually a tool to solve certain type of problems. Now, my aim is not to teach you how to solve this problem, but my aim is simply to show you that if you can rearrange a certain problem in mathematical terms that will fit linear programming, it's very likely that you will be able to solve it. Now, most of your friends in the 4th year project course, well, some groups have mathematical models that are represented with linear program. Now, linear programming is not a computer code. It's basically a mathematical statement of some equalities and inequalities with an objective function. You're gonna see a very structured way of solving these type of problems. And to do that, you need a mathematical tool called linear algebra. Of course, for simple problems, we have what we are going to see today, graphical representation. But for more elaborate problems, for problems with millions of variables, decision variables, we have a method which utilizes linear algebra. So you're gonna use the course linear algebra in another course, which is IE-102, and learn a lot of things about linear programming. My aim is not to teach that, how to solve that, but my aim is to show you another example of how we can get a statement and put it in mathematical form. So that's the objective that I have for this lecture. Okay, let's move to the next slide. Now, there is a reading associated with this, so I'm using the example in that reading. What we have is we have a shoe company that manufactures two types of sports shoes. You can call this company Nike or Adidas or something else, but here we have two types which are called airheads and groundeds. Okay, so you have two types of shoes. So probably airheads will be for jumping, very suitable for jumping. Groundeds are very suitable for walking or running. You can imagine that these are the type of shoes. Now, in a typical facility where you manufacture these type of shoes, it turns out that it is important to understand and implement a production plan. So what you're going to see today is a very simple, trivial production plan application. So this is something that you're going to see more in the third year course, which is IE-375. But the idea here is that this example forms the foundation of a number of things. One of them is, given some verbal statements, how are we going to convert that to a mathematical form? Secondly, how are we going to solve that form? And thirdly, how are we going to implement that? So we're going to see those type of things today, which will be the meat of the applications that you're going to see later on. So we are teaching the meat first, not the essence, but the meat, so that you can understand the framework in which we are going to use these type of things. Now, in the production plan, what we are interested in is simply how much of these two different styles of shoes to manufacture. Now, of course, you can say that manufacture as much as you can, or manufacturing as long as you have demand. These are true statements, but not very relevant, because manufacturing is not going to be instantaneous. Manufacturing is going to require some facilities, some resources. So what we need to do is we need to understand what those resources are, and we're going to see in this example. And we are going to see how much of those resources will be utilized if we have shoe type 1 or shoe type 2. They are not necessarily going to be the same. Now, the facts that we are given is as follows. We are given the fact that $10 profit on each pair of airheads is possible if we can sell it in the market. So it means that after we deduct the cost, the amount that is available is $10 per pair. Okay, these numbers are funny. In reality, we're talking about $100 usually for a pair of shoes. Okay? Now, the second one, grounded, which is not a very high-quality shoe, as you can imagine, the profit for each pair would be $8. So this is what we know. This is a fact from the market that we learned. Of course, we have limitations. We have limited number of workers. We have limited raw material availability. This raw material doesn't grow from an agricultural area, unfortunately. Somebody has to manufacture it. So we're talking about medium quality plastic, which is the material of your shoes, of our shoes. Well, maybe even mine, I don't remember. Okay? But the idea is that the total material which is available for this company is limited. It's buying from another supplier, and that supplier supplies a limited amount. Now, of course, you also have some prediction with respect to demand. You know that the demand of each type is not going to exceed a certain number. Now, if in the first type of shoe, if you are aiming for basketball players, the number of basketball players around the world is limited. So you cannot exceed a number of that sort. Or you don't expect everybody to buy a shoe every month. Okay? So these are the things that will put these type of limits. So these are the data that we are going to use But this is how we establish a production plan. In reality, you can take the same example, increase the number of shoe types to probably 120, increase the number of limited sources to 5. You might have 3 different types of machines that you utilize in the factory. Okay? It will be a very realistic production planning problem. Of course, what you need is you need to support your solution with the data which is available. Now, without going further, of course, if it is possible, you can immediately see that I would like to sell all possible airheads that I want to sell because the profit is more. Is this a true statement? I heard a juk. Okay? Is this a true statement? So if given this statement, do you think that I should sell as much as airhead as possible? Is that a good statement? No. Remember, we had an example in the sections with smaller sections. If you remember that example, actually we are generalizing that example. In that example, if you are only concerned with the profits and not consider the utilization of resources, then you are going to make a mistake probably. Now, airheads might bring more profit, but it might use a lot of resources. So per usage of resource, you want to give this decision. Now, the linear programming formulation or the linear programming methodology is going to handle this in a very nice way as long as you put the correct input into linear programming. Okay. Now, let's go to the next slide. Now, in the next slide is basically arrange the same problem so that we bring different things that we learned in different courses in different weeks. Now, the plan is what? We're talking about a production plan. A production plan is simply the plan where we are going to determine the quantities that we can produce. This is the decision maker's control knob over the system. I cannot change the demand this month. Like maybe I can change the demand in the long run, but here in this problem statement, I cannot change the demand. I cannot change the profit because it's sort of like very short. But what I can do is I can decide on the quantities that I'm going to manufacture. So those are decision variables. So decision variables, let's recall what was decision variable. Quantities that can change, and decision maker is able to control those. So our main aim will be using these decision variables. We will find out what is the best possible decision variable values that we can have in this context. Questions? Okay. Now, what is performance measure? In this case, the performance measure is not very difficult to attain because in this problem statement, we are only given the profit per unit. So we will be interested in the profit maximization. We will be interested in the profit as the performance measure, and our objective would be to maximize the profit. Okay? This is the way that we are going to think about a problem when we read a statement. Okay? So when you read that statement in this problem, of course we want to maximize the profit. But we still don't know how to write this in a more formal context. We're going to see it in a while. What are the constraints in this problem? What was the meaning of constraints? Constraints are limitations. In this case, there are different resources that will limit the number of pairs to produce. If we didn't have these limitations, the result would be very simple. If we had unlimited resources, okay, then the result would be very simple because we would produce the maximum demand of each type, make a good profit, and go home. Okay? Life would be very trivial if we didn't have any limitations. So constraints in this case are a formal word for limitations. So we are going to have a number of constraints as we are going to see in this case. in this case, the machining time, the worker time, the maximum demand are the constraints that we have in this whole systems structure. Any questions on this? Now, this is the connection that we have for the coming from the other weeks. Okay. Now, let us read the description of the constraints. This is page 29 of your notes. Unfortunately, it didn't come out very well. I should have tried a little bit better, but I think if it is smaller, it might be easier to read. Here, the resolution is very high. So in your notes, it will be simpler to read. Okay. So if we read this, the name of the company is the High Step Sports Shoe Corporation. I need to go down because I cannot read when I'm too close to the board. Okay. So let us figure out what are the important things in this description. So there are 6 machines to cut the materials. So we're going to write the 6 machine on one side. So we have 6 machines. I usually abbreviate machine with M/C, which might mean something else in different circumstances, like maintenance center or like Murat's Club. Okay, whatever you want to name it for. Okay. Now, so we have 6 machines. Okay. I don't think that it was that funny. Okay. Okay, but you need some relaxation. I can see that. Okay. Each pair of airheads requires 3 minutes of cutting time. So what do we mean by cutting? This is plastic, basically, or you can assume that it's some kind of a textile. It might be a textile which is enriched by use of some chemical materials. This is how the shoes are made, actually. So what they do is they first cut the shape of the shoe from a table. They put the material on the table and cut that. So it takes 3 minutes of cutting time, whereas the groundeds are only required 2 minutes. So for airheads, 3 minutes per pair, and for groundeds, so I'm going to call it G, it's 2 minutes per pair. So it takes some time, unfortunately. Now you can see that actually the profit that we had for airheads is no longer very promising. Why? Because we are using 3 minutes of our time, whereas the other one is using 2 minutes of our time, although we are making $2 more per unit profit. So you can see that immediately there is a contradiction in selecting the higher profit ones as everything, that one for production. Okay, let's move. So there are 850 workers. We're hoping that we don't have underaged workers. Okay, this is another sickness of this sector, actually. If it is manufactured in a location where the underage workers are used, then this is sort of a social responsibility that we need to think of instead of only numbers. I'm closing the parentheses. Okay, so there are 850 workers who assemble the shoes. It takes a single worker 7 hours to assemble a pair of airheads and 8 hours to assemble a pair of groundeds. So for A, I will have 7 hours of assembly time, and for G, I'm going to have 8 hours of assembly time. So this is assembly, this is cutting. Okay. Now, in the cutting, we don't have any worker involvement. In the assembly, of course, the workers does the assembly. Okay, let's move. The assembly plant operates 40 hours per 5-day work week. So luckily, this is not a location in suburban China. This is a location in urban Turkey. Okay? And also, each cutting machine is operated only 50 minutes per hour to allow for routine maintenance. In other words, you don't let the machine run continuously hour after hour. Every hour you have a 10-minute break where you maintain the machine, put everything into some alignment, clean up certain parts, maybe change some parts, and that takes 10 minutes in every hour. Okay. Now, why do we need this information? We're going to see in a while. Any questions on this information? Now, this is something that you like. I can see it from your face, because basically this is the problem data, and you have all the data available in front of you. Okay? Now, at the graduation level, you would be very happy if somebody gives you a problem like this, and you will be very happy and solve the problem. Whereas in real life, actually, you would be probably the person who would find this information out. In other words, to establish that information, to find out what is the information that I need to solve this problem, will be your responsibility. This is one of the reasons for having IE-102, because this is the only place other than the project course that somebody is going to talk about, you will be responsible for setting up this data. In the other courses, you will learn techniques, solve certain problems using those techniques. You will be analyzing the results of certain solutions. So you will be very qualified technically. But this is the course that tells you that, be careful. This is a very simple problem if somebody gives you the whole paragraph. The real problem is when you set up the whole thing yourself. Okay, so this is what you will be doing. Okay, any questions on this problem statement? Okay, next step. Now, what I will do is I will do some conversion. Now, I have 40-hour week. So how many minutes of work can a machine do? Let's do that computation. Remember, every hour, we only work 50 minutes. So it means that I have 40 hours per week. Every hour, we can only work 50 minutes with the machine. So total of 2,000 minutes per week is available. Okay? So for each machine, this is the amount of minutes that are available for cutting. Now, we have 6 machines. Let's assume that they are identical as given to us. In real life, none of the machines will be identical, believe me. Even if they look identical, they are identical. One of them will be older than the other. So the times that required for maintenance and so on will be different. There are certain differences usually among very similar looking machines. But in this case, we are simplifying. So we have 12,000 minutes per week available for cutting. Each week, this is your upper limit to cut shoes, material for the shoes. So now let's do the computation for the worker. We assume that worker doesn't need any maintenance. There is no time that we give the worker to relax during the daytime. Actually, their work hours are usually 9 hours a day. They have a 40-minute break for lunch, according to the agreement, actually. It might be different. You might have 10 minutes break, 1 in the morning and 1 in the afternoon. But in total, a worker can work 8 hours per day, okay? And so this will be a total of 40-hour week. So in that 40 hours week, we have 850 workers working. So if we multiply that, we will have 34,000 hours that of worker hours we have per week. So now this is going to be used for the assembly of the shoe. Now, of course, you can see that depending on the situation, these might be different. But the idea is that you have to make sure that the units that you are working is going to coincide with the units that are given in the problem. So this is the reason why we are doing this. Any questions on this simple, very simple, extremely simple computations? Okay. Next. Now, what we're going to do is, given all these statements, we will be representing the problem with symbols and expressions. So let's go back to the initial discussion. What was the decision variable? The decision variable was the production quantities of these shoes per week. Okay? So let's look at that. Now, number of pairs of airheads to produce per week, I'm going to call it A. Or in general, you can call it X, or you can call it T. The standard jargon in linear programming is to call it X and to put a subscript I for each decision variable. So X sub 1 would be the number of pairs of airheads. X sub 2 will be the number of pairs of groundeds to produce per week. But now, I don't want to lose the context, so I'm only writing A and G. Actually, it doesn't matter. You can use anything you want. But X, Y, or X sub 1, Y sub 1 are the usual things that are used, just to give that message. OK. But you can use anything, of course. Now, what is the objective function? Let's start with the objective function. Now, my aim is to represent the objective function and the constraints in terms of this A and G values that I don't know. So I am going to assume that A is the weekly production quantities, and I will represent everything according to this A and G. So let's start with the objective function. What was the profit per unit of A? $10. So if I produce one A, I will obtain a profit of $10. If I produce two A's, I will have a profit of $20. If I produce A airheads, and I don't know what that A is, my profit would be 10A. And if I apply the similar logic to G, it will be 8.5 G. So my objective is actually the sum of these two. Very simple, symbolically describing what the profit function is. OK, any questions on this? Now, I don't know what A or G is, but if I know, this would be the profit value. Yes?
First slide, we said that $8 profit on each pair of rounders, but we wrote here 8.5.
OK, which one is correct? Tell me. Anybody who has notes? OK, you're right. There is a discrepancy, but let's say 8.5. OK. Any question on how to write this? Now, this looks extremely simple, but believe me, when I ask the same question in, let's say, a number of hours, half of the classroom is not going to be able to answer this. So make sure that you understand the logic. OK? Make sure that you understand the logic. So what I did is very simple. You know how to solve equations, let's say linear equations. These are linear equations. And I didn't give a name to the objective function, but I could have called it Z, the objective function value. So this would be an equality where Z is equal to 10A plus 8.5G, or 8G, whatever. OK? Now, let's try to represent the machine constraint. Now, what was 12,000? Number of minutes available per week using all the machines. Now, I know that it will take 3 minutes to produce, to cut for A, and 2 minutes to cut for G. So what does this mean? It means that if I multiply 3 with the number of A's that I'm going to produce, add that 2 times the number of G's that I'm going to produce, the total time that is needed to make this production should not exceed 12,000. So this is less than or equal to 12,000. Should not exceed 12,000. What does it mean if it exceeds? It exceeds that I will not have enough machine time to do that work. So it shouldn't exceed that. So this is less than or equal to 12,000. Any questions on this? Anybody who thinks she or he understood what's going on? Okay. I will take, if you didn't raise your hand, I will take it and I will understand that you didn't understand. Am I right? Okay, let me see your hands again. Okay. Okay, good. Now, let's go to the worker constraint. The worker, okay? So you're relaxed. You learned everything. Diplomas are outside. Go home and celebrate your diploma. Okay. Okay, now the worker constraint. Okay, the worker constraint. Remember, a worker can finish the assembly of A in 7 hours. Each worker can finish the assembly of G in 8 hours. Now, in reality, is this going to be true? Are we going to have all 850 very similar, operationally similar workers? No, this is a simplification, actually. Okay? You can see that given this paragraph, the previous paragraph is extremely important. If you were to obtain that, you would be sweating by now, actually. How am I going to combine 850 workers with different experience? Okay? It's not an easy job. You're going to learn those type of things in other courses. Okay? But basically, this is the worker constraint. So you can see that 7 hours times A plus 8 hours times G, it should be less than or equal to 34,000, which is the total number of hours of workers available. Now let's do the following check. What is 7? What is the units of 7? It is 7 hours per unit. Am I right? Okay. What is the units of A? It's units. So 7 per unit times unit should give us what? Hours. So this is actually hours. So you can see that what we did is correct in the sense that it matches with the units that we have. You know these type of tricks from tests. Okay? But you have to understand this in a more relaxed way, and you have to make sure that this constraint makes sense. Okay. Now, there is another constraint which is implicit. It's not mentioned anywhere. Now, I have to make sure that the number of A's and G's that I produce is not going to be a negative number. Now, what happens if it is a negative number? Can you see what's happening if it's a negative number? Mathematically speaking. Forget about optimization. But what happens if A is negative? Okay, you don't get any profit from A. For each unit of A you produce, you are going to lose some money. But what do you gain? Okay, you see that. Let's look at this constraint. If A is negative, what does that imply? You are increasing your machining time. By having negative A's, you are increasing your available machining time. This is not realistic. You cannot make any resources more by having negative values for these type of decision variables. So you can see that A and G being non-negative is also an important part of the problem. You cannot have negative values for A and G. This is actually what we call, this is the formulation, this is the complete formulation of the problem. Mathematical formulation of the problem. What are the ingredients? You have the definitions of variables, which you want to solve for. You have the objective function, and you have the constraints. This is the complete specification of what we call problem formulation. Okay? So when I tell you to formulate a problem, these are the things that you should do if I don't ask you anything explicit. This is generally what we understand from problem formulation. Okay, any questions on this? Okay. What I will do is I will stop here now. So I will distribute the evaluations. You have two friends here who are responsible for collecting the evaluations. Now, in those evaluations, please, other than writing the grades, try to write as much as comments as possible. Note that I am not going to see those comments until late July, okay? And those are the times, so you don't need to worry about anything. If I see them, then you're in trouble. But please write as much comment as possible, and then I will see you after the break.